Mean value theorem right here. For each function and interval, determine the mean value. See if the mean value theorem applies. That's MVT for short. If it does not apply, explain what conclusions you can draw from it. If it does not apply, state why not. Oh, if it does apply, explain. Okay. So, is this function right here continuous? Mm-hmm. And is it differentiable? Mm-hmm. Okay. Then this should work. MVT should work right here. So let's do it. Let's first find the slope of the secant line, the line segment that goes through the endpoints. And so we have f of, let's do -1 first, and then we'll go minus f of 1. On the bottom, we're going to go -1 minus 1. So on the top, what do we get? No, let's do the bottom first. -2. All right, that was nice. All right, on the top, what do we get? If I plug a -1 into this, because that's my f function, let's see what we get. We get f of -1 raised to the third power minus -1 raised to the second power plus 4. Let's see, -1 raised to the third power is still -1, so we get a -4. And then this is going to still be -1. And then we have to add 4 to it. So what do I get? I get -1.
Isn't it plus?
Minus. Did I write it wrong? Oh, no, it's right.
No, you're right.
Yeah. Okay, so that's a -1. All right, now let's do it again, but let's plug in the +1. So if I do it again, let's see. Let's get rid of these guys. I'll do it again. A +1. Let's see. That would be 4 plus -1 plus 4. So I plugged in +1 to these x's. This is what I got. I get 8, and -1 would be 7. So I'm going -1 minus 7, which is -8, divided by -2, which equals 4. Now that's the slope of the line connecting the two endpoints. So slope of secant. Oh, I spelled that weird. Anyways, secant. All right, secant. Oh wait, that doesn't sound right. Let me erase that. I don't want that word anymore. Okay. Secant. All right, we got that. All right, now this says right here. Oh, what about f prime of c? What is that? That's what we have to prove, right? So we got to get f prime going on here, so that we can find that c. What value between -1 and 1 would give me a tangent line whose slope equals 4? So first I need to get my f prime here. So let's take the derivative of this. We drop the 3, multiply it to 4, so we get 12. X to the second power, because we take 1 away from the 3. Then we say minus 2x. Everybody still with me? Everybody still with me? Okay, then we have 4 equals 12x squared minus 2x. Now, since we have a quadratic, in order to solve this, we want it to equal 0, and we're going to go and try to factor this dude. Now, I don't want to factor this dude. In fact, I don't even know if this dude is factorable. So, can I show you guys a cheater way? All right, actually, it's not a cheater way. It's called using your tools appropriately. So, bust out your calculators. Okay, let's go to our calculator. All right, so I have our function inside of this calculator right now. And I'm going to press the graph button so we can look at it. There it is. All right. Our answer are the x-intercepts, the roots. So if we wanted to factor and solve this, or use the quadratic formula, oh, that actually would be the way to do it, is use the quadratic formula, you would get the x-intercepts right there and there. So let's use our calculator for that, shall we? Press the second button, and then press calc. Calc is up there. And look at that. We got a little button there that says 0. We can find the zeros. We can ask the calculator to find them for us. Yay. So I'm going to press 2. And now the calculator is asking me left bound. Now sometimes the calculator might say lower bound. It's the same idea. Left bound. So I'm going to pick... what I need to do is I need to pick an x value before and an x value after this 0 that I'm looking for. So what x value is right before it? That's a -1. So I'm going to say -1. Now I'm entering it. You can actually use the arrows to move that point thing right there to find this lower bound. And now it's asking for a right bound. It looks like 0 is after this 0. Or, the x equals 0 is after the x-intercept that we're looking for. So I'm going to put in 0. And then the calculator is going to say, okay, you ready for me to guess? It has the left bound, the right bound, and so it's going to check between these two. It's going to use a little algorithm to find it. And so after I hit enter to say, yes, please guess, it gives me my x-intercept. My x-intercept is negative 0.5, which is the same as negative 1/2. So we have x equals negative 1/2. Is negative 1/2 between negative 1 and positive 1? Yes. So this is one of my C's. But let's check the other one really quick. If I go back to my graph, it looks like this other x-intercept is also between negative 1 and 1. So we actually have two C's for this problem. So let's do that second 0 thing again. So I'm going to hit second calc and then hit 0. I'm looking for my zeros. My lower bound this time is going to be 0. I press enter, and my upper bound, it looks like 1 is right after that. So I'm going to say 1. Do you want to guess? Yes. 0.66 whatever 7. Alright, and that's the same as 2/3, since I don't like decimals. So we got negative 1/2 and 2/3. Those are my two answers. So that means f prime of negative 1/2, that would give me 4, and f prime of 2/3, that would give me 4. So what does MVT tell us? It tells us that we have two tangent lines that equals the slope between these two endpoints. So let's look at our next problem and see if we can use the MVT for this. Is this function continuous and differentiable on this interval? Now, when you see this function, you should see right away where there is an asymptote. Where is the asymptote, the vertical asymptote for this function? It's at 1, because that would make the denominator equal 0, and it would make that function undefined. So at 1, this is not continuous or differentiable. Is 1 in this interval? Yes, it is in this interval, so therefore, we cannot do MVT with this one. No MVT. And what does our question say? It says, explain what conclusions you can draw for it. If it does not, state why not. Say, because there is an asymptote between, or say in, what is that, 0, 3. Instead of in, I guess I could have wrote this thing, but then that would be weird. Let's just write in. I don't know. You can say therefore not continuous. Because that's part of the definition. It has to be continuous. So you want to say that, oh, it's not continuous, therefore I can't do it. Don't just say the asymptote. Let's be explicit. All right, let's look at this one right here. The asymptote for this one is at negative 1. Is negative 1 in this asymptote, or in this interval? No, so it should work. It should work right here. All right, so let's do it. Let's do it to it, shall we? Okay, we got let's see. On the bottom, I'm gonna have 0 minus 3. On the top, I'm gonna plug in 0, and I'm gonna plug in 3. Now we could probably do those in our head because this is a really short one. If I plug in 0 to this, I will get 1. If I plug 3 into this, that would be 3 plus 1, which is 4, so I get 1/4. So on the top, I'm going to have 3 over 4. On the bottom, I have a negative 3. Let's see, that's 3 over 4 divided by 1/3. I'm sorry, divided by negative 3. That would be the same as 3 over 4 times the reciprocal of negative 3. What is the... negative 1 over 3, right? And these 3's would cross cancel, and we all cheer, yay. So we get 1/4. 1/4 is my slope of the line connecting the endpoints. Let's find the derivative of this. We got to find h prime. Now, because there's a binomial at the bottom of this function, we must use the quotient rule. Derivative of the top, which is 0. So I don't even have to write the bottom, but I'm going to anyways to be very thorough. x plus 1, we're going to square that dude. And it says minus, and what's the derivative of the bottom going to be? 1. And then we have to multiply it times the top, which is 1. So we end up with getting negative 1 over x plus 1 squared. This is h prime. Oops, not squared, prime. So we have to see where this equals this. Negative 1 over x plus 1 squared equals negative 1 over 4. Alright, if we did our cross multiplying thing, we did this times this and equals this times this, then what we would get is 4 equals, well, negative 4 equals negative x plus 1 squared. We could divide both sides by negative to get rid of the negatives. And then we could square root both sides to get rid of that squared. So now we have plus or minus 2 equals x plus 1. Wow, that's way down the bottom of the screen. Let me raise that. Okay, let's finish it. We're right here. Whoops. We're right here. Let's go up here and do positive 2 equals x plus 1 and negative 2 equals x plus 1. So my answer is x equals 1 and negative 3. Now only one of these is in our interval. Which one is it?
1.
1. Okay, so we know that at 1, well, technically at negative 3 also. At least we think so, yeah. If at 1 we have the same slope. I mean, MVT tells us that at 1 we have the same slope as the line segment going through the endpoints at 0 and 3.